This is a short video demonstration that showcases how Heirloom's GENAI solution can provide extensive documentation of your mainframe application system. Parts of this video have been sped up to keep it short and, hopefully, engaging. Our start point is Probe, which is Heirloom's purpose-built mainframe analysis tool. Probe is built on Neo4j, an open-source graph database. In the top right window, we have executed a script to unload the database. As we can see, right now, it has no entity relationship data. Probe is now analyzing the open-source mainframe card application, which is a COBOL system that supports online and batch processing. Let's quickly check that the graph database now has entity relationship data from the analysis. We're using Neo4j's interface to look at the entities Probe has found. CC00 is the CICS transaction for accessing the system. Expanding its relationships, we can see that it is part of the card application and that the application is comprised of a set of other online transactions. As expected, when we rerun our script, the Probe file created now has a lot of metadata. For security, it's important to note that the Probe file we created contains no application source code. We're now ready to ask GENAI to document the entire system. Using Heirloom's VS Code plugin, it couldn't be simpler. In the bottom right corner, you can see the progress and a summary of the requests to Heirloom's AI. These requests are contained within a side file, which means you can easily customize the type of reports that you want to generate. The report is created in standard Markdown format, and we're going to use a viewer to scroll through the contents. This report contains a system overview, including a summary of the components. It also includes architectural diagrams generated by Heirloom's AI. This one illustrates the execution flow of the CICS transactions. Other content includes an analysis of all the batch jobs, along with an illustration of the execution flow, including all of the steps and dataset interactions. Additional architecture diagrams generated show more detailed views of how the transactions interact with datasets, how the application is organized between online and batch, data organization, and security processing within the system. So, that's AI-generated documentation at the system level. At a more granular level, we can also create documentation for specific assets within the system. The first example is asking Heirloom GENAI to document a COBOL program. Again, the content of the report is easily configured using a side file. Here we are producing a code analysis, a dependencies analysis, and a complexity analysis specific to this COBOL program. This time, we're going to ask the AI to analyze a BMS screen map. Heirloom GENAI understands we're looking at a different type of artifact, so in this report, we get a static rendering of the screen along with an overview of the different aspects of the screen. If you would like to learn more about how Heirloom GENAI can help you accelerate your mainframe modernization, contact us at heirloomcomputing.com.